Anderson. And looking at the amygdala through a sensitive period window, we know that stress leads to persistent neuronal hypertrophy and symptoms of anxiety in the amygdala. This is very enduring. It doesn't reverse with time. It doesn't reverse even when prefrontal cortex connections come in. There's been a number of studies looking at the amygdala, one of these done initially by Michael and Victor, showing in most cases no change in the amygdala, but some showing a decreased amygdala and some showing an enlarged amygdala. And it turns out that the ones that show a decreased amygdala are particularly in adults with borderline personality disorder or dissociative identity disorder. Those with increased volume have been reported in institutionally reared children with low degrees of attention or children of chronically depressed mothers. And so these studies differ in terms of the type of exposure, and they study differences in that these are predominantly adults, those are predominantly children, showing these changes in amygdala volume. We did a study with Carlin Lyons-Ruth. Carlin is an attachment researcher, and Carlin has a sample of individuals that she studied for attachment using the strange intruder paradigm at 18 months of age and has followed for the next 30 years. And so we brought these individuals into the lab and looked at their amygdala volume. And we compared them to healthy controls who we didn't believe had any problems with attachment, but we don't have the same kind of video recordings on. Anyway, what we found was a slight but significant increase in amygdala volume in the group that had early life stress. We found that it only took a small degree of stress to do that. On the right side, there was a significant correlation with degree of exposure to childhood maltreatment. Left side, there was not. And we did a sensitive period analysis using artificial intelligence predictive analytics and found that the amygdala was particularly sensitive to exposure at 10 or 11 years of age on the right side, and showed a very strong sensitive period at that time. But we didn't see anything on the left in terms of when it was vulnerable to maltreatment. But then we looked at the 18-month-old data, looking at the quality of the attachment and the disorganized attachment, disrupted maternal communication, overall attachment risk correlated, at 18 months, correlated with amygdala volume at 30 years. So that basically problems with attachment were associated many, many years later with an increase in left amygdala volume. And our thinking about that is there's two very critical developmental threats that a child faces. Very early in life, a critical developmental threat is rejection or abandonment. Later in life may be the threat of aspects of physical or sexual abuse, and that there may be a hemispheric specialization, a left amygdala being able to detect and respond to potential threats of abandonment and specializing in that way, and right being more specialized for detecting and responding to other kinds of threats. And that fits with most of the observations that enhanced amygdala response to emotional faces in maltreated individuals is predominantly a right-sided phenomenon. We also looked at the hippocampus. We know that the specs of hippocampus is to suppress neurogenesis in the dentate gyrus, to provoke the remodeling of dendrites in the cornu-ammonis, particularly the CA3. And these effects may be reversible with time. This is, again, research from Bruce McEwen, Sapolsky, Meany, very important research. There's been a ton of studies. I think there's been 37 studies published to date reporting on the hippocampus in adults with childhood maltreatment. 30 of those have shown significant reduction in hippocampal volume. That's an incomplete list. And there's also been a number of good studies looking at hippocampal volume in maltreated children. Again, Michael and Victor led the way on this. And what we found is no reduction in hippocampal volume in studies looking at younger children, some alterations in hippocampal function, and as we get towards adolescence, we start to see reductions in hippocampal volume. We modeled this in rats using a maternal separation paradigm during the first week of development. We looked at synaptic density in the hippocampus at the time of weaning, found no difference. We looked at synaptic density at the time of onset of puberty and found no difference in hippocampal synaptic density, but by early rat adulthood, there was a marked difference in synaptic density, much lower in those with early isolation stress, which persisted. So that exposure early in development may produce epigenetic modifications and other kinds of alterations that may manifest early in terms of functional alterations, but may not manifest in terms of structural alterations until a much later stage in development. And as I mentioned, it's a slice through the hippocampus. Stress affects the development of new neurons entering into the dentate gyrus. It also affects the branching of the pyramidal cells in the cornu ammonis, particularly the CA3 component. We looked at this, Carl Anderson, with 193 subjects using segmentation software and found that the subfields containing CA3 and the subfield containing the dentate gyrus were those that were most affected by exposure to maltreatment, suggesting that the same thing's happening in the human hippocampus. It's probably affecting neurogenesis and branching of the pyramidal cells. We've now done a sensitive period analysis on the hippocampus with 300 subjects, 186 females, and found that 9, 10, more 10 and 11 years of age were the period in which the hippocampus was most vulnerable in females, extended quite a bit, also some more vulnerability at 16. But around here was the peak age at which hippocampus was vulnerable in females. Interestingly, it was completely different in males. In males, it's at around 2 years of age that the hippocampus is maximally sensitive, also some sensitivity at around age 7. And the analysis that we do takes into account not just the timing of exposure, but it takes into account 10 different forms of maltreatment: emotional neglect, nonverbal emotional abuse, pure physical abuse, physical maltreatment, physical neglect, parental verbal abuse, sexual abuse, witnessing interparental violence, and witnessing sibling violence. And what we found is that in males, it's physical neglect at age 2, also at age 7, and emotional neglect at age 4 that are the important predictors of hippocampal volume. In males, it's neglect that's driving this. In females, it's nonverbal emotional abuse plus physical abuse, witnessing interparental violence, witnessing violence to siblings, and sexual abuse that's driving the hippocampal volume. So here it's neglect, and here it's predominantly forms of maltreatment that we consider traumatic that are doing that. So there's that change. Also, it turns out that the male hippocampus is much more sensitive than the female hippocampus, that the effect of maltreatment on the male hippocampus is about 4-fold greater than the effect of maltreatment on the female hippocampus. This also fits with what Michael was talking about in terms of corpus callosum and gray matter volumes being more sensitive in males. We see the exact same thing in terms of the corpus callosum being much more sensitive in males. It's a very dramatic effect. And it's likely that we're seeing a neuroprotective effect of estrogen. And that you can actually show this in animal models, that estrogen does protect against stress-induced effects on the hippocampus. We've talked about the sensory cortex and the pathways. These are, again, getting selective alterations in sensory cortex. And then we've talked about the prefrontal cortical regions, and there's lots of studies showing that the prefrontal cortical regions that we've been talking about, the ventral medial, the dorsal anterior cingulate, dorsal medial, are vulnerable to childhood maltreatment. We find that many cortical regions have 2 sensitive periods, one probably related to periods of synaptic overproduction, one related to periods of synaptic pruning. Here's for ventral medial prefrontal cortex, types of maltreatment, and peak importance. Here's for the dorsal anterior cingulate in terms of importance. And what this turns out is if you put it all together, if you lay the circuit out in terms of their sensitive period, you find that you basically have throughout development different portions of this circuit being vulnerable to childhood maltreatment, which basically means that, that childhood maltreatment will lead to an alteration in many cases in your threat detection and response circuit. But that depending on the timing of the abuse and the type of abuse, you will target different portions of this circuit. So the circuit is continuously available through development, but the different regions have their own peak periods of sensitivity. So you're targeting different components. It may show up in an fMRI study as increased amygdala activation, but in some cases it's because you've targeted the amygdala directly, in other cases because you've affected hippocampus, in others because you've affected your CEO, or you've altered your excitatory couplings or your inhibitory couplings, but you're going to get a consistent effect through different mechanisms, which may mean that they'll respond to different forms of treatment, as we're aware of that. And I think that as we really get to understand the importance of exposure during sensitive periods and the importance of types of maltreatment, we'll be able to better target the types of treatments that they'll respond to. Now, this threat detection and response system is part of the negative valence system. For those of you who are not familiar, the National Institute of Mental Health came up with this alternative way of looking at psychiatric disorders called the research domain criteria, and it posits 5 different domains, one of which being the negative valence domain, and there's others called the positive valence system, the cognitive system, systems for social processing, and arousal for regulatory systems. And my guess is that maltreatment targets each one of these domains in particular ways. We've talked about this. I think Victor presented some interesting information on this. We've approached this in certain ways. There's altered regulations in circadian rhythms and sleep. I'll talk a little bit about the positive valence system. One of the things that's also emerged as a consistent finding in individuals with maltreatment is they have an abnormality in reward anticipation. And that if you look at the reward system, which mostly is the mesocortical limbic projections of the dopamine system going to nucleus accumbens, also ventral portions of the putamen and caudate nucleus, and olfactory tubercle and some other things. This is a key part of the reward system. And you get this reward system to activate on receipt of reward. You also get the reward system to activate when you anticipate getting a reward. So if you're in a task called the monetary delayed incentive task, and you get a signal that you're likely to get a big award on the next trial, your nucleus accumbens and ventral putamen will activate in this situation. And what we've seen is that, and here's the activation of ventral striatum when anticipating a reward. And it doesn't happen that well in individuals who've had childhood maltreatment. So Dylan from Diego Pazzagali's group showed that reward anticipation led to a blunted response in the left putamen, led to a blunted response in the left pallidum. This is in women with a history of childhood sexual abuse, and it went along with symptoms of anhedonia. If you look at Romanian orphans, here's controls showing an increase in activation with mild and high reward expectation. Nothing happening in the Romanian orphans. We also, colleague Akimi Tamano and I looked at this in individuals with reactive attachment disorder, which is a rare but serious condition in which an infant or young child doesn't establish a healthy attachment to parents or caregivers, usually due to the fact that their basic needs for comfort, attention, and nurturing aren't met very early in development. And here's activation of the ventral striatum with reward anticipation in typically developing controls, and you basically see nothing in individuals with reactive attachment disorder. And doing a sensitive period analysis on that shows that what really determines that is the amount of maltreatment they experience during their first year of life. So if we think about these two things, this alteration in positive system, alteration in negative system, what they relate to is the basic phenomena of approach and avoidance. and that if you enhance your threat detection, you're going to push yourself to, or be wired to more actively avoid certain situations because they seem frightening or threatening. On the other hand, if your positive valence system is low, it's going to diminish your likelihood of approaching. And I think both of these are adaptive in terms of pushing individuals to avoid potential dangers. And sort of the message is don't anticipate reward, expect to be maltreated. But if you experience reward, what happens is these individuals keep at it, which then heightens their addictive risk. So, okay. Next to the last part. We've gone from talking about regions to circuits. So you can also think about this in terms of the network organization of the brain. This is work that we're doing with Kyoko Ohashi. And there's lots of ways of looking at brain network organization. You can look at it in terms of fiber tracks. You can look at it in terms of resting state functional connectivity. You can look at it in terms of between subject correlations in thickness, which go along with these regions being highly interconnected. And you can then start to look at how each brain region is, how strongly each brain region is connected to another brain region, and you can map this into an entire network and analyze this using graph theory and start talking about alterations in network architecture. And it's very interesting, long and complicated, so I'll give you the short version of this. We did this in about 256 subjects looking at a network that encompassed the entire cerebral cortex. And we had 112 cortical regions, and we looked to see how centrally important each one of these regions is. And there's a variety of techniques for looking at central importance. The one that relied on the most was looking at something called the Eigenvector Centrality, which uses the same kind of computation that Google uses in its PageRank algorithms to tell you which web page should come up first in your list. So it has more highly interconnected connections to other web pages that are also very popular. And so we were able to look at the eigenvector centrality of different brain regions, and we found that there were about 9 of 112 brain regions that were significantly altered in the maltreated network. The biggest alteration was in the left anterior cingulate, and this is left anterior cingulate in green. The purple circles represent its direct connections, and the blueberries here are the secondary connections, the friends of friends. And this is the connections of the left anterior cingulate in the unexposed controls and in the maltreated subjects. And this was dramatic. This went from being the most important node in the unexposed brain to being about 99th out of 112th in the maltreated brain. So you really lost the central importance of your left anterior cingulate. And it goes a lot of studies showing reduction in size or integrity within the anterior cingulate. That also happened in the left temporal pole. There are 2 regions that showed a dramatic increase, one of which was the right precuneus, which went from being a relatively unimportant node in the unexposed region to being a very important node in the maltreated. And also the right anterior insula went from being a relatively unimportant node in the unexposed brain to being an incredibly important node in the maltreated brain. And this may go along with what Victor showed in terms of right anterior cingulate activation going along with PTSD scores. Now, the anterior cingulate plays an important role in the regulation of emotion. It's involved in interoceptive awareness. The anterior insula is involved in interoceptive awareness, subjective feelings, and possibly self-awareness. And the precuneus is a major component of the default mode network. It's involved in self-referential, self-centered mental imagery. And the default mode network is markedly overactivated in individuals with depression and diminished by effective treatment. And so maltreated individuals may be at increased risk for psychopathology due to reduction in the central importance of the anterior cingulate decreased ability to regulate emotions, and coupled with increased centrality of the anterior insula, increased emotions, self-awareness, internal perceptions, and increased in the precuneus, which leads to self-preoccupation, self-referential thinking. And so this may also help us understand these individuals. And interestingly, psychotherapies are often designed to target different components of these by enhancing emotional regulation, diminishing self-referential thinking, diminishing preoccupation with bodily sensations. Last area I want to talk about is the idea of eco-phenotypes. And what I mentioned in the beginning is, 50% of the population attributable risk for depression is due to childhood adversity. And so with a group of individuals with depression, you're going to find a large subgroup that have had maltreatment and also a significant subgroup that has not had maltreatment. And this is, and Christine provided some interesting data on the differences between these subjects. You also see the same thing in post-traumatic stress disorder. You'll see individuals with PTSD who've had childhood maltreatment. You'll see individuals with PTSD who was exposed later in life to traumas who did not have childhood maltreatment. You'll see this in people with substance use disorders. You'll see this in individuals with generalized anxiety disorders. Vast majority of psychiatric disorders will have a maltreated and a non-maltreated subgroup. And the point that I would like to argue is that these individuals, maltreated and non-maltreated, are clinically, neurobiologically, and genetically distinct. And that this is one of the crucial, important distinctions in psychiatry. The ones that have the maltreatment will have an earlier onset, more severe course, more comorbidities, greater symptom severity, poor response to treatment, and as we also heard, it's the maltreated ones that are probably going to show problems with inflammation. They're going to have cardiovascular symptoms. The ones who have migraines are the ones who've had a maltreatment history. They're going to have autoimmune problems. They're going to be very different from the group that has not had a history of maltreatment. Reduced hippocampal volume. A number of studies now have shown that reduced hippocampal volume is specific to the group of depressed individuals that have had maltreatment, and that you don't see it in non-maltreated individuals with depression. Hyper-responsive amygdala you'll see in depressed individuals or PTSD individuals with maltreatment, not particularly in those individuals who haven't had maltreatment. And so that studies that compare DSM clinical groups to controls and which do not collect data on early life stress will provide inconsistent results based on differing prevalence rates of early life stress in their clinical control group versus other researchers' samples. And researchers studying different disorders may find the exact same abnormalities. Everybody finds hippocampal abnormalities. Everybody finds anterior cingulate abnormalities. Everybody finds amygdala abnormalities, no matter what disorder they're studying, because all of their patient populations are enriched in early life stress. And so there's basically 8 different psychiatric disorders that are associated in the literature with reduced hippocampal volume. All of these 8 different psychiatric disorders are markedly increased in incidence by exposure to childhood maltreatment. So how much is these disorders that are related to hippocampal volume, and how much is maltreatment an unrecognizing and critical confound in all of these studies? So last part, we've been doing a small study looking at mindfulness as an intervention with individuals with early life stress. This is done by Diane Yan and Sarah Lazar. And it's just a mindfulness-based training versus waiting list control, looking at pre and post imaging, hippocampal cognitive task, and functional connectivity. Symptoms go down in the individuals with receiving the mindfulness. A hippocampal memory task shows improvement. There's an increase in gray matter volume for left hippocampus. The specific subfields of the hippocampus that are reduced increase